Okay, so good afternoon, students of CS 6201. Okay, again, welcome to our virtual class for this afternoon for computer organization and architecture. So now our topic is about the introduction of assembly language. So the assembly language notation, or the ALN, so it is a type of a low-level programming language that is intended to communicate directly with a computer's hardware. So unlike machine language, so which consists of binary and hexadecimal characters, assembly languages are designed to be readable by humans. So the RTN stands for registered transfer notation, is easy to understand but cannot be used to represent machine instructions. Mnemonic can be converted to machine language, so which processor understands using assembler. So assembly language uses a mnemonic to represent each low-level machine instructions or opcode or operation code. So typically also each architectural register, flag, etc. So most assemblers permit name constants, registers, and labels for program and memory locations, and can calculate expressions for operands. So we have a given example of labels. So it is an identifiers that serve as place markers within the program for either code or data. So these are replaces in the machine language version of the program with numeric addresses. So we use them because they are more readable, like move, location, or lock in, or add. So the instruction mnemonics are abbreviations so that are identify the operation carried by the instructions. So we have move, or MOV, move a value to another location. Add two values, or add three values, or add R3, R2, or R4. And then we have also a sub, yung SUV, subtract a value from another. We have JMP, or jump to a new location in the program. We have mul, or MUL, so which means multiply two values. And call a procedure. So another example, we have, let's say, adding a numbers like the operation code and each operand. We have move EAX, comma, and then 1000. So it means that it copies 1000 into EAX. Or add EAX, it adds 4000 to EAX. Or sub EAX, comma, 2000. So it means that it subtracts 2000 from EAX. So the register transfer notation, or the RTN, so it is a way of specifying the behavior of a digital synchronous circuit. So an example of a high-level RTN is the Verilog, and a low-level example is register transfer language. So the RTN may be written as either abstract or concrete. So a way to describe micro-operations capable of being performed by the data flow, the data registers, the data buses, functional units, so at the register transfer level of design, so which is the RT. So also describes conditional information in the system, so which cause operations to come about. So the type of instructions. So we have the 3 instructions or the 3 address instruction, the 2 address instruction, and 0 address instruction. So when we say instructions, so in assembly language, it consists of a name or label, an instruction mnemonic, operands, and a comment. So the syntax or the general form or format is we have the operation source 1, source 2, and its destination. Or the general form is that we have name, mnemonic, operands, and its comment. So example, we have the operand or opcode and its operand. We have add DEF, where DEF are memory location. So it means that it adds the DEF, okay, to its memory location. So it is a simple statement. So our free form, they can be written in any column with any number of spaces. So between each operand, so as long as they are on one line. So the advantages or the advantage rather and disadvantage. Advantage, single instruction can perform the complete operation. Whereas the disadvantage, instruction code will be too large to fit in one word location in memory. So the DEF is a data. So it is a data statement allocates storage in memory for variables. So we have the 2 address instructions. So the syntax, we have the operation source, and its destination. So like for example, move EF or move DF or add DF or add EF. So perform add EBC using 2 instructions. So move BC or add AC. So in 2 address instructions, so it is a format of machine instruction. So it has 1 opcode and 2 address fields. So 1 address field is common and can be used for either destination or source, and other address field for source. So in 2 address instruction format, we have the opcode, the destination source 1, and source 2. So this advantage, single instruction is not sufficient to perform the entire operation. Then we have another example. We have x equals to a plus b multiplied by c plus d. So the solution we are going to use is yung move, add, and multiply. So we have move R1A. So it means that we add A in its memory location. So we add A to R1 or move A to R1. And let's say we have add R1 to B. So it means that R1 plus B. So B, it's in memory location. So B add into R1. And then we have the 1 address instruction. So the syntax, we have the operation source and destination. So in this type, either a source or destination operand is mentioned in the instruction. So other operand is implied to be a processor register called accumulator. So the 1 address instruction is also a format of machine instruction. So it has only 2 fields, one for opcode and other for operand. So example, we have add B, load, add, and store. So load D, accumulator. So ang nasa memory location niya is the value D. And then add E. So accumulator plus E, and store in its memory location is the letter F. And then another example, we have the X equals to A plus B multiplied by C plus D. So the solution we are going to use is load, add, store, and multiply. So what is the difference between the two address instruction and the one address instruction? So in two address instruction, so it has three fields. So it has one field for opcode and two fields for address. So it has long instruction length as compared to one address. So it is slower accessing location inside processor than memory. So it generally needs two memory accesses or accesses. Whereas in one address instruction, it has only two fields. It has one field for opcode and one field for address, while it has shorter instruction length and it is faster accessing location inside processor than memory. It generally needs one memory accesses. So another, we have the zero address instruction. So location of all operands are defined implicitly. Operands are stored in a structure called push down stack. So in zero address instruction is a format of machine instruction. So it has one operation code or opcode and no address fields. So it means zero address instruction format. So a processor supports the arithmetic logic unit operation. So one data in memory and other in register, then the instruction sequence is move, add, and move. A processor supports a loop operations only with registers, then one has to follow the instruction sequence given below. Load, add, and move. So the basic instruction cycle. So the basic computer operation cycle, we have fetch the instruction from memory into a control register, decode the instruction, locate the operands used by the instruction, fetch operands from memory if necessary, execute the operation in processor registers, restores the results in the proper place, then go back to step 1 to fetch the next instruction. In instruction cycle, a program residing in the memory unit of a computer. So it consists of a sequence of course. It consists of a sequence of instructions. So these instructions are executed by the processor. So by going through a cycle for each instruction. So in a basic computer, each instruction cycle consists of the following phases. Like yun nga, fetch instruction from memory, decode the instruction, read the effective address from memory, and execute the instruction. So in computer architecture, input-output devices act as an interface between the machine and the user. So the instructions and data stored in the memory so must come from some input device. So the results are displayed to the user through some output device. So the instruction execution and straight line sequencing. So as instructions are a part of the program which are stored inside the memory. So every time the processor requires to execute an instruction, so for that, the processor first fetch the instruction from the memory, then decodes the instruction and then executes the instruction. So the whole process is known as an instruction cycle. So the straight line sequencing. So it means the instruction of a program is executed is in a sequential manner. So every time the PC is incremented by a fixed offset and no branch address is loaded on the PC. So example, here, programs and data are stored in the same memory, like in von Neumann architecture. The first instruction of a program is stored at address I. So PC gives address I, and instruction stored at that address I is fetched from the memory and then decoded, and then operand A is fetched from the memory and stored in a temporary register, and then the instruction is executed. So the content of address A is copied into processor register RO. So side by side during the coding or the execution, the PC gets incremented by 4. So it contains the address of the next instruction because the instruction in memory segment is of 4 bytes. So the instruction at address I is executed. So every time the PC is incremented by 4, therefore the program is executing in a sequential manner. And this process is called straight line sequencing. So PC or program counter holds the address of the next instruction to be executed. Straight line sequencing, if fetching and executing of instructions is carried out one by one from successive addresses of memory, so it is called straight line sequencing. So the major 2 phases of instruction execution. First, instruction fetch phase. Instruction is fetched for memory and is placed in instruction register, so which is the IR. Second, instruction execute phase. So the contents of IR is decoded and processor carries out the operation either by reading data from memory or registers. The next, we have branching. So what do you mean by branching? So branching is a basic concept in computer science. So it means an instruction that tells a computer to begin executing a different part of a program. So rather than executing statements one by one. So branching is implemented as a series of control flow statements in high-level programming languages. So branching is the practice of creating copies of programs or objects in development to work in parallel versions. So we have a straight line program for adding numbers, and also we have using a loop to add n numbers. So a branch in a computer program is an instruction that tells a computer to begin executing different instructions. So rather than simply executing the instructions in order. So in high-level languages, these are typically referred to as flow control procedures and are built into the language. In assembly programming, branch instructions are built into a CPU. So branching is a basic concept in computer science. So it means an instructions that tells a computer to begin executing a different part of a program. So rather than executing statements one by one. So branching is implemented as a series of control flow statements in high-level programming languages. So it is include also the if statements, yung for loops, while loops, and goto statements. So branching instructions are also implemented at the central processing unit level. So though they are much less sophisticated than the kinds of instructions found in high-level language. So these instructions are accessed through assembly programming and are also referred to as jump instructions. So branching instructions are those with which changes the normal sequence of execution. Sequence can be changed either conditionally or unconditionally. So accordingly, we have conditional branch instructions and unconditional branch instruction. Conditional branch instruction changes the sequence only when certain conditions are met. Unconditional branch instruction changes the sequence of execution irrespective of condition of the result. So branching instructions refer to the act of, it means switching execution to a different instruction sequence. So as a result of executing a branch instruction. So the three types of branching instructions are, we have jump, call, and return. So jump, unconditional, and conditional. Call, unconditional, and conditional. Whereas return, unconditional, and conditional. So the jump instruction, it means that it transfers the program sequence to the memory address so given in the operand. So based on the specified flag. So jump instructions are two types. Again, the unconditional jump instructions and conditional jump instructions. Whereas the conditional jump instructions transfer the program sequence to the described memory address only if the condition is satisfied. The condition codes. So the conditional code flags, the processor keeps track of information about the results of various operations for use by subsequent conditional branch instructions. So the processor keeps track of information about the results, okay, of various operations, of course. The NZVZ, okay, our bits are the condition code flags. So you can set them by arithmetic and logical operations. So they can also be set by MSR and LDM instructions. We have N for negative. So 1 if results are negative, 0 if results are positive. Where Z is equals to 0, 1 if results are 0, 0 if results are non-zero. V for overflow, 1 if arithmetic overflow occurs, 0 non-overflow occurs. CK if 1 if carry and from SSB bit, or 0 if there is no carry from MSB bit. So the N, Z, C, and V bits are the conditional code flags. So you can set them by arithmetic and logical operations. So again, they can also be set by the MSR and LDM instructions. So all instructions can execute conditionally in the ARM state. So the format and the different instructions type. So the computer performs a task based on the instructions so provided. So the instruction in a computer comprises groups called fields. So these fields contain different information. So as for computers, everything is in 0 and 1. So each field has different significance based on which a CPU decides what to perform. So the most common fields are the operation field specifies the operation to be performed, like addition. And we have also the address field, which contains the location of the operand, like register or memory location. The mode field, which specifies how operand is to be founded. So instruction is of variable length. So depending upon the number of addresses it contains. So generally, CPU organization is of three types. So based on the number of address fields. So we have the instruction format and the instruction types. So that is the format and different instruction types. The processing the instruction. So simple computer, like most computers, uses machine cycles. So ang cycle is made of three phases. Again, fetch, decode, and execute. So during the fetch phase, the instruction whose address is determined by the PC is obtained from the memory and loaded into the IR. So the PC is then incremented to point to the next instruction. So during the decode phase, the instruction in IR is decoded and the required operands are fetched from the register or from memory. So during the execute phase, the instruction is executed and the results are placed in the appropriate memory location or the register. So once the third phase is completed, the control unit starts the cycle again. So, but now the PC is pointing to the next instruction. So the process continues until the CPU reaches a halt instruction. Okay, so thank you for listening. So have a nice day to all of you. So I'm Dean Jane.